The elimination method is a method that can be used to solve a system of equations of any type of system. However, there's a couple rules that you have to follow. The first rule is that all equations must be rewritten into standard form. So when we talk about standard form, we're talking about ax plus by equals c. Now the other piece about it is that these equations, to use the elimination method, should not be fractions or decimals. Okay, they should not be pieces. If you find that you have an equation that is a fraction, one thing you could do is you could multiply the whole fraction by its denominator in order to get rid of that fraction, thus making everything whole numbers. Or if you don't feel like doing that, then your fallback method is the substitution method, which uses any type of number. So here we're going to look at specifically the elimination method, and in order to do the elimination method, there's a couple steps that you have to follow. First, you have to start by choosing your variable to eliminate. So right off the bat, looking at your equations, you need to decide, are you going to eliminate, for example, the x or the y? Some instances it's very clear in that the variable to choose is standing out at you. A couple rules that you have to follow for eliminating a variable is that to properly and successfully eliminate a variable, you need, first is opposite signs, and second is the same coefficients. As long as you have those two ideas, then you should be able to successfully eliminate a variable. So like I said, in some instances it's going to be totally apparent what you need to eliminate first, but in others you may have to create it. To create it would mean that you simply have to multiply one or both of the equations by a constant in order to get you to have opposite signs and the same coefficients. Once you have that, you add your equations together. So in adding them together, what we means is we are doing old school vertical math or vertical addition. So in other words, you want to think back to your elementary days when we used to line numbers on top of each other and add them vertically. Well, we're going to do that with our equations. Once you get it down to a single variable, again, you're either going to have one solution, no solutions, or infinitely many. If you have a one solution system, meaning you find the answer to one of your variables, then you simply substitute that answer back into the original equation to get the other. If you have a false statement, then you have no solutions. If you have a true statement, then you have infinitely many solutions. So let's take a look at a couple examples here just so that you can see how this works. So we need to solve using the elimination method. So the first thing that you need to do is you need to choose what to eliminate. So I'm looking at my equations and notice my x variables have the same coefficient but they have the same sign. My y variable has the same coefficient but they have opposite signs. So here I would eliminate the y. So this says that once you choose your elimination, you need to add them together. So this is where that old school vertical math comes in play. So we have x plus y equals 13, and we have x minus y equals 15. We are going to add these together, and so essentially the way it works is we have x plus x is going to give me 2x. x plus or y plus a negative y means this goes away. 13 plus 15 is going to give me a 28. So notice old school vertical addition. Now I need to just simply divide everything by 2 and I end up with x equals 14. Now if you look, this automatically means that we have a one solution system, because it is this step that's going to dictate what you do. Now that we know what the x is, I have two equations to choose from. It does not matter which ones you choose, but your third step is going to be to solve for the remaining variable. In other words, the one that you eliminated. So we eliminated the y, now we have to solve for the y. So we have x plus y equals 13. My x was 14, so this is going to be 14 plus y equals 13. Take this 14 and move it. So we have that y is negative 1. Here is my second solution. So this means overall I have the solution 14, negative 1. And this is my total answer. Now obviously this is a one solution system, so that means the other thing that we could do if you were asked would be to classify your solutions. But there you have it. Alright, let's look at this next one. Here, if you look, notice I have x minus 3y equals 1, and I have a negative 2x plus a 6y equals 5. My x's have opposite signs but different coefficients. My y's have opposite signs but different coefficients. So no matter what, I'm going to have to multiply. So again, the first thing I have to do is I have to choose. And in this case, let's go ahead and eliminate your x's, only because in the last example we eliminated the y. So in order to do that, I have to multiply. So I have x minus a 3y equals 1 and a negative 2x plus a 6y equals 5. My goal is to add them together, but I need to have the same coefficients, so I'm ignoring the rest of the equation and I'm just simply looking here at what it is that I have to do. So in order to get these to be the same but opposite signs, I need to multiply this top equation by a 2. So I'm going to multiply this entire top by 2. So when I do that, distribute the 2 through the whole thing, and we get a 2x minus a 6y is equal to 2. And then down on the bottom I still have my negative 2x, and I am now free to add them together because my goal is now opposite but the same. So negative or 2x plus a negative 2x means it goes away. And now I have negative 6y plus 6y gives me a 0. And I have 2 plus 5 gives me 7. However, you should notice this is a false statement. Because this is a false statement, this means we have no solution, and therefore there is nothing else for us to do. Now, as a side note, take a look at these equations. X minus 3y equals 1, negative 2x plus 6y equals 5. If we look closely at them, notice this top equation is already simplified, But this bottom one here, this here, we could simplify it. Essentially, if we look at the negative 2x plus a 6y equals 5, if I divide everything by a negative 2, then here, negative 2 over negative 2 leaves me with x. 6 divided by negative 2 is a negative 3y. And then this is going to be negative 5 halves. So just simply by simplifying the equation, if I put them back together, my system now looks like x minus 3y equals 1 and x minus 3y equals negative 5 halves. If you look closely, what is this telling us? Well, this tells us I have the identical ax plus by part, but I have different c parts. Therefore, the lines are parallel. Parallel, if you remember, parallel is a special case, which means no solution. So the other thing that we could have looked at when approaching this problem is we simply could have looked at the equations as they were given and notice that they are actually the same equation with just opposite or different solutions, thus making them parallel lines. Now, here's where I caution you. If you are asked to solve using the substitution method, then the work that you are being asked to show is this work right here, which means that this side note would simply be a way to check your solution. Okay? So be very, very careful that when you are working these problems, you are working them the way that you are supposed to get the answers that you are supposed to. Now, let's look at this next one. Some students get to the point where you can look at an equation and you can see right off the bat that there is really not much that has to be done. So simply, if you look at this equation, if we were to just simply add this right off the bat, what you're going to notice is that negative 4x plus a 4x becomes a 0. Negative 2 plus a 2 becomes a 0. Negative 12 plus 12 becomes a 0. This is considered a true statement, which means that we have infinitely many solutions. Okay. So that's what the elimination method looks like if you either A, have a one solution system, B, have a false statement or no solution system, or C, have an infinitely many solution system. So if you have any questions, please let me know. Otherwise, relax, have some fun, enjoy your elimination method, and I'll see you next time.